Welcome, my name is Pedro Plaza and I'm presenting the topic Learning Scenarios with Arduino from the Module 5 Deploying Educational Content with Scratch, Scramble and Arduino. This material has been prepared by Blanca Quintana, Aluria Peixoto, Manuel Castro, Elio San Cristobal, Antonio Menacho, Manuel Blázquez, Sergio Martín, Guillermo Botella and me. Along this topic we will see the key elements to work, key elements to interact, the traffic light, brain energy laboratory, and finally we will be talking about the conclusions for this topic. The key elements to work with Arduino are the electronic assemblies, computational thinking, automated constructions, interactive systems, and also remote applications. The key elements to interact with Arduino are the LEDs, servos, sensors, and motors and communications. The traffic lights have lights to regulate the movements of vehicles and lights to regulate the passage of pedestrians. For this case, using the Arduino tool, we will be connecting the power supplies. As you can see, we are using a USB cable to connect a power bank from RS and the Arduino using the USB port. And the LED strip will be powered with the power ports of the Arduino. And we are connecting the control signals of the Arduino and the 144 LED strip. To use these LED strips and the program in a simple way, we are using the Fast LED library, and to install this library you have to click on Tools, Manage Libraries, and in the window that will be appeared you can write down Fast LED and click on the Install button to install the library in your Arduino IDE. To program an LED you can use the following program. As you can see, we are defining the data pin for the port 9. We are choosing a LED type as WS2812 and the color order as GRB, and the number of LEDs this has matched with the LED strip. We are using in this example 144 LED strip, and we can select the number of LEDs and as 144. We are using the class CRGB for manage the LEDs. This class is called in our program as LEDs, as a matrix with the number of LEDs. And in the setup we configure a delay of 5000 milliseconds, and we are using the function add LEDs from Fast LED library and the set brightness from the Fast LED library. In the loop, in the main loop function, we are using a for loop to manage all the LEDs to red color, and we are waiting for a second, and then we change the color to green. And for the blinking we are using two for loops to set the LEDs in yellow and to set the LEDs turn off. As a challenge for this example, you can use some LEDs of the strip for the vehicle sequence and the other LEDs for the pedestrian sequence. The vehicle sequence could be red, green and yellow, and the pedestrian sequence could be red, green and flash green. If a vehicle can pass, the pedestrian must stop, and vice versa. The second learning scenario is Wine Energy Laboratory. For this learning scenario we are using an Arduino One, a sealed breadboard, one wine generator, 4 LEDs, 4 resistors of 100 ohms, and 7 DuPont male cables. And in the image you can see the connections are very simple. more complex than the Crumble connections, but they are not too much complex. And this is the scheme of the connections. As you can see, we have to connect it to the GND or 0 volts of the Arduino port, all the LEDs, and we are connecting the digital ports and its LED with a resistor. We are using digital port 2, 3 and 4, and we are using the analog port to get measures from the wind generator to get the current. As you can see, this is an example of use. We are defining the ports, the green LED, yellow LED and red LED, and in the setup we are configuring the ports as output to manage the LEDs, and we are using the port A0 as input to get the current measure from the motor, and we are also using the serial port to communicate the computer and get the samples if we want. And in the main loop, we are defining the voltage value, and we are assigning the analog read of port A0 to this variable, and we are printing in the serial interface this value. And in the following steps we are selecting, depending on the voltage level, which LED can be blinking. The red, the yellow or the green depends on the voltage value. With this laboratory we can acquire in the voltage value, send data through the serial port and setting the appearance of the LEDs. In the following video you can see conclusions for this topic are that the students can work with electronic assemblies, computational thinking, automated constructions, interactive systems and remote applications. When we are using Arduino, the programs can interact with push buttons, LED lights, digital sensors, analog sensors, communication networks, servos and DC motors. And the learning scenarios can be the real world. The learning scenarios can include handmade constructions, lights, motors, servos and sensors, and the learning scenarios can also include communication networks and remotely accessed applications. Thanks for your attention, and I hope you enjoy this content and the MOOC.